Okay, so let's just have a look at some of the key, I guess, differentiation skills from what would typically be our methods course. First up, the derivative with respect to z of sine squared z. Okay, so that's just the equivalent of it being sine of z all squared, isn't it? So that's, which really makes it just a chain rule. So if we just sort of step it out and put u equal to sine z, and then v is equal to u squared, derivative dv du is 2u, the u dz, derivative of sine is cos z. So then the chain rule says that we work out the product of those two derivatives, cos of z times 2u, obviously substitute our u back in, and we get a 2 sine z cos z, which for all intents and purposes could easily be just sine 2z. I guess the second one is a more obvious chain rule application. We put u equal to 5x squared plus 3. The derivative of that is 10x. The derivative of tan u is sec squared u. Again, the product of the two derivatives, 10x times sec squared of the original 5x squared plus 3. So hopefully that's all okay. The final one here, we've got a quotient rule. So remembering, I think it doesn't hurt to step the quotient rule out. So u equal to x squared, v equal to sine x, v dash is cos x, du dx is 2x. So we get order is obviously important, the order derivative of the top times the bottom function minus the derivative of the bottom function times the top, all over the bottom function squared. So then in this instance, if we sort of group our terms together, you could possibly take x out as a common factor, but it doesn't achieve a real lot. Probably there's our answer there. Given we're in a specialist environment, we might turn everything into cosecs and cots, etc. But don't know, a bit questionable whether we want to go that far. All right. So this first exercise, just touching up and brushing up on our differentiation techniques with methods.